Hello, welcome to the 8th episode of Reactive Programming in Angular video course. Last time we've been looking at reactive forms, and today we'll keep looking at this topic. However, we're going to introduce some new techniques. You're going to learn about the scan operator. That's a new RxJS operator that we haven't talked about yet. And what's more, you're going to learn about how to implement your own Redux pattern. You have probably heard about Redux as it's quite popular recently. There is the Rx library, which is quite popular. It's based on Redux and it's implemented specifically for Angular. There is also the Redux library itself. However, Redux is also a name for an architectural pattern and it's really easy to implement with RxJS, so that's what we are going to do today. The use case we are going to implement is a form undo mechanism. So imagine having a very complex form again, and the user is filling this form and suddenly they type a lot of text and they accidentally deleted this text. So our form backup mechanism won't help us. However, we'll introduce a form undo mechanism so the user can undo his last action or a couple of his last actions and retrieve the piece of text that he entered previously. So, I'd like to remind you that if you like this channel, please subscribe it. It really gives me motivation to record these videos. So, without further ado, let's get to work. Okay, so in order to implement form undo, we will need to keep track of form history. So we will build an array and we will be adding to this array whenever there is a change in the value of the form, and whenever there is an undo, we'll be popping from this array. But this array is actually the piece of state of our component. And we don't like to have a mutable state in a component. It's not really the functional reactive way. Instead, we are going to use something that kind of follows the Redux architecture pattern. So, in simple words, we are going to have a stream of actions and we are going to write a reduce function that takes an existing state and an action and returns an updated state. So maybe let's start by defining what is an action in our case and what is state in our case. So we are going to have two actions. One will represent a change in the value of the form, and another action will be an undo action. So let's create a generic interface for actions. So it will have a type as a string and payload as any. And that's a very generic interface. So now let's move on and see what the state is in our case. So another interface for state. So as I said, we would like to build up this array of form history. So it's just gonna be a history array. We don't introduce any specific type for the value of the form. We will just keep it simple, so it's any. And we are going to need another piece of information that might not be obvious at the moment, but we will find it useful later. But let me add it now. It's going to be an boolean field. I'm going to call it undoing, and it will tell us whether the undo has been clicked or not, whether we are in the middle of the undoing action or not. Okay, so the next step would be to introduce a stream of actions. So, as I said, there are two actions. One will be the value changes action, and the other is undo action. So for undo action, we are going to need a stream of clicks on the undo button, which is something that we already did in previous episodes, so it should be familiar. So let me create a new stream here, a subject actually, undo click stream, which will be a new subject. The import is wrong, subject. And now to the template, and I will call next on this new stream, undo click stream, on the click event on the button. So now I have two streams, the stream of undo clicks and the stream of value changes from the reactive form. So I should be able to create a stream of actions from there. And I will do this by merging these two streams. So let me declare the action stream, which is going to be an observable of action type, which was defined below. And now, as I said, this action stream will be created by merging. It's from RxJS operators merge those two other streams. So this undo click stream and this band form value changes stream. Although I need to map items emitted on these streams to actions first. So for undo click, it's rather simple. I will just always map to the same thing, which is an undo action. So type is undo. And for the other stream, I need to map it to another stream of actions, which is, let's call it as, the type will be value change now, and now we will have some payload, and that payload will be the value emitted by value changes stream. So I need some brackets here, and also make sure that payload is actually optional, because I don't provide it for the undo action. And let's see what's wrong here. It seems that I imported merge from the wrong place. So it's not operators, it's observable, because I'm not interested in merge operator to provide to pipe function. I'm interested in the merge function. So the error disappeared and it looks nice now. Great, so now I have this stream of actions and I'm going to transform it to a stream of states. And this is actually the core of the Redux pattern. So for that, I need a function that transforms state and an action to the next state. So basically it applies action on some given state. So I'm going to call this action reducer, and it's going to take state and action and return, of course, updated state, but for now it will just return the same state. So that's an identity reducer so far. And now I also need something called initial state, because I need to start with something, right? So the initial state, in my case, it's going to contain a history, which will be empty to start with. And also, we will set the undoing flag to false, just to add the type annotation that this is of type state. And now to put it all together, we will use a new RxJS operator called scan. And I'm not sure if you are familiar with the reduce function of arrays in JavaScript. But basically, the way it works is like you have an array and you can call reduce on it. So it takes a function that takes two arguments. The first is the so-called accumulator, and the second one is the next element from the array. And it should return a new accumulator for the piece of array containing the new element. So for example, it's very easy to implement summing the elements of an array with a reduce, because accumulator will contain the sum for the array traversed so far. So given an accumulator, let's say for this piece of array, and the next element, we return the accumulator for the piece of array containing this next element. So reduce is also available on streams, and it works the same way. So you provide a function that takes accumulator and the next event emitted by the stream. And once the stream completes, the new stream will emit a value with the accumulator. However, this is not exactly what we want. We want a slightly different variant of this reduce operator. We want a scan operator. And the difference is that scan will emit the current state of the accumulator on every event emitted by the source stream. So we don't need to wait for the stream to complete, which is good because our stream of actions will never complete. But what does it have to do with our problem? So this reducer here, it takes an accumulator and an element, and this is exactly what we want. We want our accumulator will be the current state. The element will be an action because we will reduce over the stream of actions, and we will return an updated state. So let's now put it all together. So we'll create a state stream, and we will start with action stream and call scan operator on it. And the scan operator will take the reducer function and the initial state. So once again, we reduce over the stream of actions. We start with our empty initial state, and for each new action, we take the existing state, we apply the action on that state, and we return a fresh new updated state. So we end up with a stream of state objects. So now it's time to implement the meat, the actual logic of the undo function, and the logic will be here inside the reducer function, because this is the place where we apply actions on state. So instead of returning the same state, we will actually take a look at actions type. Maybe let's add some type annotations here. So this is state, state, and action. So action.type. And there are two cases here, value change and undo. So for both of these actions, we need to apply them on the existing state. So let's start with value change, the simpler one. We'll simply return a new state. And for the undoing property, we'll always say false. But for the history property, what we want to do is to take actions payload, which is the current form value, and put it at the end of the history array. So we can do that with spread operator. So state.history we unwrap it, and at the end we put action.payload. So maybe let's give it a quick test now. Just to make it all work, we need to return something here. So for now, we'll simply return state here. And also let's subscribe to this state observable and write it to console. And let's run the application. Okay, so the application is loaded. Let's see at the console, and already we have emitted one state here, which says undoing false, and the history contains a single element with form value. And this is because in the onInit method, we applied the state from local storage. So that's why the state was emitted here. Okay, so now let me type something here, like Metallica. And we can see that for each keystroke, there was a new state emitted. So let's take a look at the last one. So the history array now contains 10 elements, and we can see the history of the form very nicely here. Like after every keystroke, a new element was added to this array. Of course, if I change the year, for example, the same thing happens. The history array keeps increasing. So you might worry about memory at this point because this array will grow very fast. There are different things you can do about it. One is to apply debounce time on the stream of value changes to only get updates after some period of inactivity. So that would limit the amount of events. And the other thing is that we don't really need to hold the whole history. We might decide to only store the last 10 states and no more, because we may not allow the user to undo indefinitely. Okay, back to the code. We've taken care about value change action. Now we are going to take care about this undo action. So while we were adding the new state at the end of the history here, we will actually remove the last element from the array in this case. So we'll return undoing true, but for the history array, we are going to do state.history.slice from 0 to state.history.length -1. So we are removing the last element from the array. Okay, so now our stream of states is fully functional. We can now take advantage of it, make use of it, and whenever there is an undo action, we will apply the last element from the history array on the actual form. So we'll set the form value to the last element from the history array. So we already see why we need this undoing flag here. So here, where we subscribe to states, instead of logging to console, let's do something more. So yeah, we can still log to console because that's nice to see what's going on. But if there is some undoing going on, we are going to take hold of the form and use the setValue method in order to apply the state. So let's take state.history, and we want the last element from the array, because the array always holds the history and the current value of the form is at the end. But after processing the undo action, we have already removed the last element from the array. So if we look at the last element again, it will be actually the previous state of the form. And there is a tricky part here, because this call will trigger the value change stream to emit a new value. And the way it's implemented now, when this new event is emitted, it will be translated into a value change action. This value change action will actually cause this state to be added at the end of history. And we don't want that because we are in the process of undoing. So we don't want this previous state to be added at the end of the history. So what we have to do is take a look at state.undoing. And if state undoing is true, then we simply return history unchanged. And only if it's false, we will append at the end of the state history array. Okay, so now we are ready to test the new functionality. So let's go to the browser and let me type something in the name field, Slayer. And now if I click on the undo button, I can see that the change was reverted. So if I change this active checkbox and undo, this also works. There is a small problem with that. If I keep undoing, I will reach the beginning of history and there will be an exception here. So maybe let's fix this problem. So this happens because here in undo, it might happen that state.history array is already empty. So in this case, I don't want to reduce its length. So maybe let's have a check that if history.length is smaller or equal to 1, then I simply return the same state, history. Otherwise, I apply slice method on it. Let's give it a try. So now if I type Slayer here and click undo a lot, I don't get the error anymore. And one more thing at the end, I will add this debounce time and on the value changes stream. So as I said, I don't want to record every action, but only if there is period of inactivity of the user. So here on the value changes stream, maybe before calling map, I will add debounce time here. So now if I go to the browser and let me type Slayer here quickly, I will see that only one state was emitted. So the history is a bit cleaner now. But if I do it slow enough, like this, then of course the state is emitted for every keystroke. Okay, so that's it. That's a working undo functionality created in a pure reactive programming way. We took advantage of the reactive forms in Angular, but also we have applied the Redux pattern locally, so in the scope of the component. But thanks to it, we don't have any mutable state in the component. Our state is represented in the state stream, observable, and it's immutable. Only the new values of the states are emitted, but we never modify existing state. Alright, that was actually quite a lot of stuff. I hope it's clear enough and I explained it well. If I didn't, please let me know in comments and I will try to help you understand the Redux architectural pattern and the scan operator. It's actually really important that you understand this because, as I said in the introduction, Redux is getting more and more popular and it would be really great if you understood it and could even build it from scratch using RxJS. So that was the last episode I have planned for this course. There might be more, but probably not on a regular basis. If you'd like to know about the new episodes, please subscribe to this YouTube channel, and also you can visit my blog codewithstyle.info and subscribe to the newsletter. I will definitely send an email whenever I record a new episode. So that was it. Thank you very much for watching. Thank you very much for reaching this far. I hope that you've learned a lot and this course brought you a lot of value. That's what I intended to do. Again, thanks for watching and see you in next episodes.